So you can now, instead of having to type this, you have to do they're the people hosting it, tinyurl.com/ then can't even say that right, HOEOHQT. Much, much, much easier to type. You can do a Google search for ASD parent math resources. It comes up quickly sometimes, and sometimes it's buried. So if you have the URL, that is easier.
You do a search on LiveBinder too. If you go to
LiveBinder
and you type in this,
right.
It'll come up, because I know I have to do that.
But it doesn't say LiveBinders up there and all that stuff. Yeah. So that was my new learning, that I can take a long URL and they spin it through an algorithm and spit it out with a URL that nobody would ever choose is really what it is. And you just go through their site. It should stay linked. And apparently it drops 1 in 10 times. I'm not worried about that. We're going to wait about 2 more minutes, although I think 13, 15 people signed up, and some of them were ASD employees. Then we realized it was sports day, so I don't know if they're coming.
No, all the teachers enrolled.
Yeah.
There is no class.
Which explains why I was able to get the room so easily.
That's always suspicious.
Maybe that's why.
Yeah. So Carol, do you need anything else?
No, thank you. No, you need to go to sports day.
Yes, I know.
I had many people volunteer to help me. It's like, no, you have to go to sports day. It's like the room was available,
Yes.
and it's not conflicting with something that demands parking. That's the first 2 things we go to. So it'll be just a minute. Again, it's going to be 50 minutes for a 5-week lesson. It'll help you. Thank you.
It's wrong.
Yep. Yes. Right. HOEOHQT. I did my learning early in the day. I learned one new thing. Okay, I'm going to get started just because some of the stuff at the end is pretty important. Multiplying and dividing fractions, I would venture to guess most of us learned 2 rules. We memorized them and we hopefully remembered how to do them and have not necessarily needed to use them since you left a math class. As you know, we want our kids to understand a lot more than that. I memorized the 2 rules, couldn't remember which one was division and multiplication, so I took a problem I knew the answer. I applied the first rule. If it didn't work to the known answer, then I knew it was the other rule. That is not an understanding of mathematics. So this is the beginning of multiplying and dividing fractions. They get to fluency in this in 6th grade. We're building the foundation and the understanding of it in 5th grade. So we do build it a bit with them. Building it becomes cumbersome, so we switch to pictures pretty quickly. You'll see that, especially in the multiplying, the kids will absolutely figure out the algorithm because the pattern is so strong. But we have them build it and stuff so that they can understand where it came from. First thing we're going to talk about, though, is that fractions are actually a form of division. And that hasn't been highlighted until the last couple years. So this is kind of a standalone explanation. 6 halves means 6 divided by 2. So if I was to take this, I've given you colored pencils. Yes. You're going to need them later especially, but when you write with your regular pencil, it blends in with what's on the sheet. If I was to make this tape diagram 6, 4, 5, 6, and I divided it into 2 parts, I get the answer. How many are in each part? 3. And I realize this is for the video. I'm going to have to do it in pen. So this is just a mathematical truth here that we don't necessarily think about. It's very easy when it's whole numbers like that, but it's true of the fractions also. 1/4 is, we took one whole, we divided it into 4 pieces, and what is the value of that one piece? Well, it's 1 out of the 4, so it equals 1/4. This is my whole. No, excuse me. I want to divide 3/4. Make sure I'm doing this one right. Oh, I'm sorry. This is 3 divided by 4. How are we going to do that? It would be lovely if it was 3/3 because I could divide it into 3 pieces. But I want this divided into 4 pieces. I'm going to take each one and divide it into 4, each part divided into 4 parts. So how can I group these together to get 4 equal pieces? 1, 2, 3, I get a whole. 1, 2, 3, I get a piece, I should say. 1, 2, 3, I get a piece. So I took 3, dividing them into 4ths, I get the answer. How many is in each of these pieces now? It's 3/4. So if that doesn't matter. So let's do another one, because that was the beginning of the weirdness, I would imagine. So if we have 2 divided by 3, and this is where real pieces help. Can I, you agree with me that I have 2 pieces. Can I divide that, let me get color. Can I divide that into, which problem am I on? Can I divide that into thirds? No, I can't. How could I make it so I could divide these into thirds? Well, I can break it apart, each one into thirds. Does that make sense? Now I can get 3 pieces out of this. Here's one piece, here's a second piece, and there's the third piece. And how many, what's the value of each of the pieces? 2/3. So this is just a bit cyclical. Usually you wouldn't, because I'm teaching you this, I wouldn't have there to begin with. So if I took this away, 5 divided by 3. I got my 5 pieces, divide each into 3. But I need to end up with 3 parts. So how many of these are going to go together to end up with 3 parts? It's going to be 5, 5, and 5. So our answer is 5/3, and we could simplify it and make it 1 2/3. This is just a fact. So it's just this idea that later on in math we will be talking about this is a division problem, and this is how they can solve it. I picked nice fractions where we actually used the numbers that was in the fractions. Let me think. If I had done, yeah, I don't want to do one. There are times when you can use other fractions. You would have just gotten a simplified fraction. All of these were simplified. So this page is, he says, just kind of accept it, but you'll hear the kids talking about, oh, that is a division problem. That is a very important piece of knowledge for algebra. Why, when we have x over y, it means x divided by y, or 2x over y. It's really 2x over 4y. It starts explaining, well, you were dividing that and working it out. So this is the time when we first prove it to them. It's kind of a standalone piece of knowledge right now for them. So we're going to move on to the multiplying and dividing. Your kids have been doing tape diagrams for a couple years now. They're pretty used to them. They didn't see them as much in 4th grade. The 5th grade teachers are saying they're using them pretty fluently now as a way to reason. So we're going to be using these today. There are 32 students in a class. Of the class, 3/4 of the students bring their own lunches. How many students bring their lunches? Tape diagrams are about part, whole. We know the whole. It's 32 students. 3/4 of the class. Well, I can break that into fourths. I know that 3/4 brought their own lunch. How many was that? Well, I know if these are each fourths, it's got to be 32 divided by 4 for each section. So there'd be 8 students here, 8 students here, 8 students here, and 8 students here. Now I can ask a lot of questions. How many brought their lunch? How many didn't bring their lunch? How many more brought their lunch than didn't bring their lunch? We now understand what the numbers are. We can answer a lot of questions. So this is where we tell the students they have to go back and write an answer statement. Now I need to go back. What was the actual question? How many students bring their lunches? I go back, I colored 3 of these, so 24 students bring their lunch. And this is just a story, but there is an equation that goes with it. At this point, we're not even asking them to do that. We're making sure that they can visualize it and figure it out, and we'll get to the more abstract as the unit goes along. So the next one, I didn't give you a story, but 1/6 of 24. What's our whole?
24.
So our whole is 24. I need to divide this into 6 parts. What's the value of each one of those parts? How are you going to figure it out? Yeah, we've got 6 parts, so we need to divide it up equally. This is 4. This is very related to what they are doing in 3rd grade, but it would be 24 divided by 6. They would see it the same way. But now we're taking the 1/6 and understanding that it's a division problem. I shouldn't say it that way. We can solve it this way by dividing into 6 parts. This one doesn't have a question. All it would be is the diagram there. The next one we need to read carefully. New York Rangers hockey team won 3/4 of their games last season. If they lost 21 games, how many games did they play in the entire season? How are you going to start this problem?
So they lost 1/4 of their games.
So how would we?
It was 21. 1/4 of their games is 21.
Yes.
So 3/4. I have to do it here.
Okay, so how is this going to look? We need, the diagram has to show fourths. And then we can start labeling things. 3/4 was what? How many they won. So this part is how many they lost. What else do we know? They lost 21. So this area is worth 21, this area is worth 21, and this area is worth 21. Now I need to go back and make sure I answer the right question. How many games did they play the entire season? 21 times 4, which is what, 84.
463 plus 3.
And this is where they have to go back to the question, because most of us probably wanted to say they won 63. But that wasn't the question. That's that importance of the answering statement, because even I was going there. I mean, I've done this 3 times in the last week. So I go back to the question. So the final answer is 84 games were played.
I don't understand the part 1, how come each is 21? We know that the last 21. How did
The
you-
one we,
Because these are all equal. We divided these into fourths. Fourths are always equal pieces. Yeah, good question. Did you have a question? Yeah. So, the fractions. Sorry, we couldn't start back at the beginning. Fractions are always equal pieces. And to compare fractions, we always have to compare them to the same size.
Now I understand more.
Yep. I'll tell you, 3rd, 4th, and 5th grade have all just started fractions, so I've been giving these things. So please ask those questions because it's so in my head. I've been doing all the levels, so if I skip over something, thank you. Okay, would you do the Abby spent 5/8 one, and I want you to talk at your tables. Do you get the same answers? I have no idea why the word "the" is at the end.
Okay, so that's, so that, yes, okay, so she's not spent, yes, yes, okay.
All these together.
It's 7,
So do you agree with the drawing that's up there so far?
We draw 8.
Right?
And, but I thought he spent it. One part I said, I know that he spent $45.
She spent it on 5/8 of it. So 5 of the parts equal 45. So what would one part equal? It's 9, isn't it? So if this one equals 9, each one of them equals 9. That's 9 times 5 is 45. So I know that each one, and I have 8 parts. So personally, I'm going to multiply 8 times 9. I could add 45 plus 27. I should get the same amount. So Abby spent, no, she didn't spend. Abby had $72 to begin with. So I'm not sure if you've seen this come home on your student's paper where we're saying you have to label it. The labeling is what shows us that you understand the problem. And when you start getting into these problems, you can see why that makes sense.
No. The one before, why we didn't divide 21 by 3 and then in each A1 will be 7. like if we have to compare the proportion.
Okay, let's go back to what it says. They won this many games, 3/4 of it. We were then told the amount that they lost.
Okay, I compare that he spent $45. So I thought like he
Spent 5/8, so you can see that I drew, here's my 5/8. And I also know that that same 5/8 equals 45.
How do you get 9?
45 divided by.
Oh,
I've got these 5 parts, and I have to have an equal value out of the 45. Yes, by 5th grade, your kids need to know their times tables. Okay, we know as educators, kids need to know their time facts. That's different than just holding up flashcards and memorizing them. So in 3rd grade, they spend half the year understanding what multiplication is and how to break them apart and be able to put them together. At this time in 3rd grade, they are starting to play games where they learn them fluently. So there's this, they're arguing over semantics, the word memorization versus fluency. Memorization implies that you know that 3 times 7 equals 21. Fluency implies that if you know 3 times 7, but you don't know 4 times 7, you can reason. I can do 3 times 7 plus 7. So there's that flexibility with the numbers. So it's the numeracy. So if we take away the semantics, they need to know their multiplication table. How many of you know 8 times 8?
64.
Very good. The most common one not to know. Most adults use some sort of trick to get to 8 times 8. 8 times 7 is right in there. 9 times 7, although I don't understand the 9s because we all have all these tricks for 9s. So the idea of fluency and automaticity is, yeah, you may not, we're not asking it in 1 second. We're not doing on-demand, boom, 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 like I just did to you. It's the idea that within 3 seconds, they're not using their brain power to figure out 45 divided by 5. They're using their brain power to figure out this word problem. And by 5th grade, they really should have this to automaticity, with that exception of maybe 5 that they figure out. But they should have a way to figure out those 5 that are fairly simple for them. I did not, my bugaboo was 8 times 7. I would just have to figure it out each time until somebody told me a trick. It's, if you write it backwards or whatever, it's 5, 6, 7, 8. I can now remember it's 56. It's counting numbers. So we do get to this part where we use the tricks because I completely understand what 8 groups of 7 is or what 7 groups of 8 are. So yes, by 5th grade they should have these. I will put up on the parent resource a page of games that your kids should be playing because if they don't know them, they really ought to. With the exception, I will tell you, there are 2 to 3 kids, out of 140 kids, there are 2 to 3 kids with memory issues that they're not going to learn them. So we give them the multiplication chart. But that's for the very special cases. Most, by far, are fully capable of learning this number of facts. And it's not that many facts, because if you know 4 times 9, you know 9 times 4. And that's part of the 3rd grade curriculum. By 5th grade, that should be very obvious. So you're really only learning half. Everybody knows 2s, everybody knows 5s. If you know 2s, you should be able to double to get 4s. So it's time to know them.
And my daughter's not very quick with them though. She can get to them, but she's not super fast.
I've heard the rule of thumb is 3 to 5 seconds.
Is it?
Which isn't really very, very fast.
No, okay, so I'm being hard on her.
I would rather have her flexibility and trying to figure it out. I mean, one, play the games, she's going to pick up a lot of them. But it's not as dogmatic and as quick as we used to think it was necessary. I mean, can she look at this problem and within 5 seconds, assuming she understands what to do, I'm not getting there, that she sees that this is 45 divided by 5.
Yeah, that you can work
So
it out.
listen, that's 45 divided by 5. Can she get it in that
Okay,
5 seconds?
all
It's-
right.
That's fine. She's not wasting a lot of energy,
Okay.
but she should know her
I'm
5s.
expecting her to like, if I ask, she should answer.
Yeah. You know what I would do? This is a fairly complicated question.
Yeah.
On a much simpler question, I would just watch to see if she's getting there fluently is kind of the term we use. If that's not where she's getting frustrated, if you start seeing them count on their fingers because they're skip counting, that's too slow.
Yeah, okay.
Um,
I mean, look, she is performing well in math. She's getting 3s pretty much consistently. So, I mean, it's not, but I just think, she's getting 3s, but she's struggling with her multiplication. Like,
I would give the playing the games a try.
okay.
And we're talking maybe 10 minutes a day.
All right.
10 minutes a day is far better than 2 hours at one sitting on the weekend. We know how the brain works. Spaced practice over time is better than one
So an
sitting.
hour or whatever.
I would give her a chance to get better at them. And she still may have we call them the bugaboos, just the ones that she's going to catch.
Okay.
You want to introduce X and Y at this
No,
point?
no.
Because for me it was easier to just put X.
Right, as I said, fluency and the solving. We're trying to make sure they understand what's going on here.
So you want to apply it at this stage yet?
No, no. I mean, we use X and Y, like 5 times 4 equals X.
Yeah.
But we're not solving for X.
Yes, that's what it works.
Okay, the last one I want to give you, because it's far more real life, struggling readers would have a difficulty with this one because you do have to read it carefully. So, just for the sake of time, we have 30 cupcakes. Spreads mint icing on 5. I'm going to divide this into 5 parts, and I can label this as mint. And chocolate on half of the remaining. That word remaining is important because now I'm not looking at the mint. I can see that it's 2 out of the 4 get chocolate. And the rest will get vanilla icing. Okay? I now have everything labeled. Now I just have to figure it out. How many equal pieces do I have?
5.
I have 5 equal parts or pieces. So each of them is worth 6. Now I can figure out, well, there were 6 mint, there were 12 chocolate, and 12 vanilla. But the question only asked me about vanilla, so there were 12 vanilla cupcakes. I can tell you this diagram is far faster than finding for X and Y.
Exactly.
Yeah.
And that's what we're trying to show those of us who always learn to turn it into an equation. Logic and pictures are a really strong resource. Back to, it's another tool in our toolbox.
They have to learn to label it right because that's where
And this is-
label it wrong,
And
then
the
whole
kids
thing
want to
is-
say, but I know, and I'll tell you, we get parents and everyone go, why label? They got the answer right. Well, on the simple one they did, but what happens when it gets trickier? And for struggling readers and second language learners, we have teachers helping them saying this question is unfair. We've now learned that we made things so easy 10, 12 years ago in the guys. We were trying to be nice of, let's just make sure they understand the math. It wasn't math, it was arithmetic. We broke it down to just straight numbers, which actually, numbers without context can be far more difficult. I mean, at this point, we have no equations. Kids are totally able to figure this out.
So when it says show your work,
This
That's
is what we're
math?
expecting.
ah,
Yeah. The visualizing of the math is important. The context has to be here. The new kind of definition is mathematics is the real world of applying the arithmetic. Arithmetic is 3 times 5. Nobody walks into a grocery store and has a clerk walk up to you and say, what's 3 times 5? So the real world application is now what we're considering mathematics. You can use your arithmetic, you can use logic, you can use manipulatives, and we move them along the way that we get to the more abstract. However, we discovered, we took logic, I shouldn't say logic, we took reasoning out of math a long time ago and we're bringing it back. Yeah.
I have to say that it's kind of embarrassing that I would not have been able to come up with this picture. Because I've been helping my son the last 2 nights. And I've had to pass it off to my husband because I'm trying to do the equation. And I know that's not what he's learning, but I don't know how else to help him without the equation.
And I'm
Now
sorry
that
we
I
didn't
see
have
it-
this 2 days earlier. We have to book these things out months in advance to get this room. And we never quite know. I mean, we have the date when they say they're gonna start. It's usually a week later. I mean, so we try to get these at the beginning.
It makes complete sense now. I'm just embarrassed that I couldn't have thought of that.
You were never shown it.
Yeah.
And when you can't, the best thing to do is turn it on them. So what'd you do in class today? Well, we understand what you did in class. The thing is, it's actually best for them also. And even if they can't get the whole, even struggling to get to something like, it's like, well, I knew we had this bar and we had to break it up into pieces. That's gonna help both of you kind of go, well, why would I break it up into pieces? How many pieces would I break it up into? So you really don't have to know, but here's your support. This bar diagram, it's called a tape diagram. Tape diagram and bar models are the same thing. I don't know why they had to give them 2 different names. I just got exposed to it 4 years ago, and it's like live in some of these shows. Okay, but we are going to get to the algorithm. The common misconception is that when you multiply 2 numbers together, your answer gets bigger. That is absolutely false. It only gets bigger if your numbers are whole numbers. Well, whole numbers are mixed numbers. If you have fractions, your answer gets smaller. So we really have to put this to the kids. So this is, there is 2/4 of a chocolate bar left on the table. Jane came in from playing and ate 1/2 of it. Okay. I know I have 2/4. At this point, we are asking them to draw an area model, and we're being pretty prescriptive in how we draw it just so we can have the same conversation. I'll be honest, we could have started horizontally first, but we don't. We needed to pick one or the other and go with it. The world of teaching is picked to draw vertically first. So there's 2/4 there. I ate 1/2 of it. Now I'm going to take this piece, this drawing, and cut it in half the other direction. But I only get half. Some people draw just the part with the 2/4. I tend to draw it across. Where does this area overlap? Where is the pink and the green together? Right here. So how many pieces, or what part of this bar do I get? Well, I got 2 pieces out of 8. Simplifying fractions is not the must it used to be. But what's cool about this, okay, I can be a math dork, is you can also see that 2/8 equals 1/4. I can see that I have 1/4 here, here's the second, here's the third fourth, and here's the fourth fourth. It also proves the simplified fraction or the equivalent fraction of 1/4. We're not worried about that at this point. Most of the kids do it because they know it, they learned it well in 4th grade. But this picture explains to them where all the numerator and denominator came from. So if we look at the next one, 1/2 of 1/3. I'm going to draw my third. I get half of it, I draw the other direction. And at this point, I can also look at it. There's my 1/3. I get half of it. The reason I need the whole picture is I don't know the denominator. I don't know how many pieces it was broken into. When I look at that whole piece, I can. It was broken into 6 pieces, and I got 1 of them. So 1/3
The half
of 3/4. Excuse me?
Okay.
So 1/3 of 3/4. Draw the 3/4. Now, there's always one delightful child who doesn't think in the box. And that child is so helpful to the discussion. Because I want to see what happens. I would be the rule follow and I would have colored it 3 stripes in a row. Are we going to get the same answer? Well, I need 1/3, okay? I break this into thirds. I color 1/3. I'm that child, I'm going for the middle third. How many areas overlap?
Good morning. If your radio station this morning.
Okay, that's sports announcement, no emergency. How many overlap of 2 colors? 3, and out of how many total? 12. Did anybody do it the rule follower way, right in a row? How many did you get? Same. And if somebody drew it another way, this is a really great conversation that we want the kids coloring it different ways to show that we got the same answer. We did the same process. It doesn't matter. I would then talk to a lot of kids that your brain likes patterns, and for most of us prefers it together, but I'm not going to make a child do it together because mathematically you've got the same answer. And I tell you, there's 2 of these kids in every single class that really cannot bring themselves to do the 3 in order, and that's fine. They're understanding the math. So we've moved from giving you the story to giving you how we read a multiplication problem to what it looks like in multiplication. Back in 3rd grade, they were taught that 2 times 4 is 2 groups of 4. That is the language of multiplication. So we're now, when we've got the multiplication problem, it is still 2/3 of a group of 2/5. So we are going to draw the 2/5. I have 2/5. I have 2/3 of it. And top or bottom obviously doesn't matter. I usually go on the bottom. So I got 4 out of 15. I'm not going to do the last one with you, but I want to show you what happens. What happens if I draw it the other way? If I had done 2/3, and I multiplied it by 2/5, I still get the answer 4/15. So although we say 2/3 of 2/5, the commutative property doesn't matter which way you draw it. We do talk about it with the kids. They're used to talking about multiplication that way, but it really doesn't matter which way they draw it. Now we've drawn this, and we've drawn this, and we've drawn this with the kids. I start collecting all the data up on the whiteboard, and we start seeing that 2/3 times 2/5. Oh, I'm writing in space I'm going to need. Let's do it up here. 2/3 times 2/5 equals 4/15. 1/3 times 3/4 equals 3/12. 1/2 times 1/3 equals 1/6. And I put that information up on the board, and I just look at the kids, and they look at it, and all of a sudden, whispering starts. I mean, she's a fool. You can just multiply numerator times numerator and denominator times denominator, and you get the answer. Yes, you can. That was the only way I was taught. I didn't understand why, or I didn't understand how to prove it. So we will get to that pattern, because the kids, I get it, they don't want to draw it all the time, but I need to know that they understand why it works. And that's as far as we get, and if a child really didn't get there this year, I would be okay with that. That is actually fluency of multiplication, but it's only fluency of a fraction times a fraction. It gets more confusing when it becomes a mixed number. And although we may build that, we're not doing that with the arithmetic. That is 6th grade. I promise you we'll get there. Does that make sense? So this is the model we're using. Wish I had it written right here. Santino bought a 3/4 pound bag of chocolate chips. He used 2/3 of the bag while baking. How many pounds of chocolate chips did he use while baking? This is called the area model. They can draw the area model of 3/4 of a pound and then 2/3 of it, and they'll get an answer. I know that it will be 6/12. The multiplication, as usual, is easier, but we're going to move on to the division. The division, we especially stay in the world of manipulatives and drawings in 5th grade, and we stay in the world of models, whole answers. We stay with particular problems. It is a beginning understanding. So we go back to our bar graph diagram. If I have 1/4 divided by 3, that means I've got my, I wish I'd done this. So this is my whole of 1. So I only have 1/4. Can I divide that 1/4 into 3 parts?
Yes.
Yeah. How do I figure out the value of that 1/4? Well, if I broke the first 1/4 into 3 parts, I have to break each one of them. So now, to understand what's going on, I need to do that to all my parts. So what is the value of this piece? That's 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1/4 divided, I'll put that here, by 3 equals 1/12. Yep, look at it. Back to the beginning. I took my 4th, I divided it into 3 parts, but now I need to know what that name is of that piece. Let's do another one, see if it makes sense. Pardon me?
It's too early in the morning.
Okay, plus you haven't seen this. This is new. So if I have 1/3 divided into 2 groups, I have to get to my 3rd first. I want to chop my 3rd into 2 groups. What am I going to name this part? Well, they have to be equal parts. So A is 1 out of 1, 2, 3, 4, 5, 6.
So we got the one from A, B, 6.
Yeah, so this was, and this is where labels would help. This was my 1/3. Too close together.
So we spend all this time making it equations, and now we have to spend more time to visualize,
Yeah.
right? Because
So-
it's
But
better.
we're not, yeah, we're making sure the kid's getting the visualization first. We know that that connection is very important.
So is that part left hand side is 1/6?
Yeah, A is worth 1/6.
Oh, A is 1/6.
Yeah, A is. I didn't have the name for it yet, so I called it A. Does that make sense? Because you probably learned, oh, I don't even know the rhyme anymore. It's not your place to do or die, just invert and multiply. And I was like, well, which one do I invert? Which one? And then I never knew whether it was multiplication or division. I can figure this out. It's not due to a silly rhyme. Does it work? If I had inverted the 2, of course, then you need to know what invert means. Would I have gotten the correct answer? At 5th grade, that would just be pure memorization, not an understanding.
So how do they come to a conclusion, say it is 1/6 on the A part?
Okay, do you, if I don't have that part there, we have our 1/3 and we divided it into 2 groups, right? So we're looking at this group. I need to know what to call it. And if I hadn't drawn those in yet, I don't have equal parts. We know it's a fraction, so I know I have to divide this third into 2 parts and this third into 2 parts.
Yeah, agreed, but how do they get 1/6?
Because they can count it. They've got 1 out of 1, 2, 3, 4, 5, 6.
Okay, okay.
Okay? Yeah, so it's visibly there each time. Sybil has half a pizza. She wants to share the leftover pizza with 3 of her friends. What fraction of the original pizza will Sybil and her 3 friends get?
This is little bit harder for this division.
Oh, yes.
Yes.
Yeah. And we don't, this is about, well, this is as far as we take it.
Yeah.
And we're very, at this point, we're very particular with our fractions and our questions so that they're not ending up with remainders that they'll get to do in 6th grade, which we used to have to do. So we're pleased that they're just getting this foundation. Okay, so I have half a pizza. Please stay with a rectangular pizza. Circles are very hard to draw accurately. But we now know that this is just a representation of the map, so it's not a pizza. So if I have half, but I want to share it with Sybil and 3 friends, how many parts am I breaking that half into? 4. That'll catch some of the kids. Okay, so I've got the 1/2 of the pizza. What is the size of this particular piece? How would I give it a name? So if there are 4 parts in this half, how many parts are there in the other half? 4. So the starred piece, or whatever you want to call it, how large is it? It's 1 out of. So they would get 1/8 of the original pizza. We are not trying to trick them. We needed to say mathematically it was out of the original pizza. It's a very different question if we say what fraction of a piece did they get out of what was left, because then it would be 1/4. Because technically the whole changed. We're not trying to, that is not the point of this. We're not trying to trick them with language. So, that's a fraction divided by a whole number. I'm going to draw a big line right here because we're changing ideas. Now I have a whole number divided by 1/2. And the language becomes very important. how many groups of one, it's the same as above, you just can't, it doesn't help you. The above, it was, I have how many groups of 3 in 1/4. That doesn't help me get to the answer. When we switch the numbers around, how many groups of 1/2 are there in 4? Yeah, there's 8. Can we prove it? So I'm going to label this for you. This is 1, so my total is 4. How many groups of 1/2? I'll have 1 here, I have 1 here, I have 1 here, 1 here, I have 1 here, and I have 1 here, and I have 1 here. So I could have figured that out logically. The natural answer from 5th grade, before they think about it, is 2. That is the common misconception. Because they see 1/2, they think, oh, it's half of 4. That is not the question. That is a multiplication question. It's how many groups of 1/2. That is the biggest learning curve on this part of the division. So we give them the language. We transfer those symbolic notations into language that they can understand.
How many groups of half, right?
Yep. And again, back in 2nd grade, they read 4 divided by 2 as how many groups of 2 were in 4. So we've used this same language for them to understand it. So now it's how many groups over 1/2, or how many halves are there in 4. And kids will figure out pretty soon, well, if I know how many groups are in 1, I can then multiply it by 4. But that's the kids who are really thinking and looking for the patterns and have good numeracy. So 5 divided by 1/3, what is the question? How many 1/3 are there in 5? Well, I have 3 in the first one. I'm going to do it 5 times. So how many thirds do I have? 15. Without drawing it, this surprises the kids in the beginning. Because again, well, I don't know how they'd have a hard time. 5 divided by 3 would end up messy. And they could do it with a remainder. But that's not the question. So we have to get them used to not jumping at the numbers, but thinking about what's being asked. My goodness. Oh, good. I'm only 2 minutes late. That's really close. So the last one, in context. Mrs. Silverstein bought 3 mini cakes to a birthday party, or for a birthday party. She cuts each cake into quarters and plans to serve each guest 1/4 of a cake. How many guests can she serve with all her cakes? I need 3 cakes. I cut each one into quarters. How many kids can I serve? How many groups of 1/4 are there in 3 mini cakes? Yes, thank you.
So 14, 12.
Is it 12?
12.
And I would argue this is where I would have started the lesson. In context, it's easier to understand than what we call naked numbers. Because there's more of a reason. I can picture it in the context. I can take that real life context, put it into my representation, and it makes sense. So really, when people used to complain about word problems, it's because we didn't help them with it. Word problems really help you understand what's going on. I mean, I think that particular problem is where I would start, and then make it more abstract. And honestly, they do. This is for you. Please, this is a 5 or 6 week class. Do not go home and try to show all this new learning to your kids tonight. They're not ready for it. They take it slower, they get more practice, they ask the questions, they talk about it. But now you understand what they're being exposed to. Our philosophy is you really should never have to teach your own child. You're here to support them. If they really don't get it, I need to know that as the teacher. I don't really need to see your work. On the other hand, support is great. You're nudging them along, you're giving them that try. Getting them to explain it as much as possible. I'm sorry, they're all off to sports day.
But I don't even know the curriculum. What do they do? Now I know they do fractions because there was a message.
Yeah, there should be letters home.
Yes, well, I knew.
Oh,
It's
okay.
my first week. I got a letter.
Oh,
I saw
okay.
fractions, division.
Right.
And I thought, okay, he can do that. But I don't know what they'll do the whole year and how. Am I going to go and say, okay, let's do this complicated fractions. Show me how you visualize it, how you do it in
Yeah.
class. No, I don't do that unless there's a problem.
Right. There are, I'm gonna get myself in trouble here. There are parents who so want to help their child succeed that they think pre-teaching is a good idea. And they teach them their way.
He wouldn't let me.
Yeah. You see, by 5th grade, they've got more of a voice. But that's just what we're saying. We want your support. We hope you've chosen to come to this school because you believe in us and that we have chosen the right approach for doing it. When you come in new, there's a gap time of making the philosophy of where you learned. We all get to the same place in the end, I promise you that. But we just want the kids to have that flexibility and understanding of the math. It is an American school. We do use the Common Core standards. You could look them up. I could help you find them, that you could look at what the standards are across the 5th grade level. I don't know if you care that much.
I do care, actually.
Okay, let me talk to you. See, coming in now, yeah, that you don't have that whole picture of what's being done. Thank you for coming. You can go peek outside and watch an awful lot of fun happening out there. It's probably just getting started. This is probably the last one for 5th grade for this year. After that, they're going to do volume and measurement, which is just far more hands-on anyway, and a lot more. It kind of makes sense. You won't need this. If you could put these down, I will pick up pencils. I need to figure out how to turn off that camera.
Turn it off.
You'd think it would be obvious. Close that. That didn't turn it off.
Record button now. Record button.
Where's,
This one. Yeah, just press.
I'm wondering if it's on the other side.